H2O. Wow. Who's new with Azure? Okay. Who's new with HD Insight in Azure? Great, so half of it is new. Okay, so we have everybody's new in H2O, half of people is new in Azure, in HD Insight, and 30% is new in Azure. Okay, my name is Pablo. I am a data solution architect for Microsoft. So my job is to help enterprise customers, like big enterprise, AT&T, and all these guys, to move their workloads to big data, machine learning, and IT workloads to Azure, and beat the crap out of AWS. Right? That's my job. I can tell you what beat the crap out of AWS. So one of the things that I did in conjunction with the product team and the marketing team the last 3 months is to bring H2O to Azure, specifically to HD Insight. And Jorge, which I want to introduce right now, is going to tell you about big with H2O, with Azure. And when you talk about big data, you have to think about Spark, you have to think about Hadoop. Granted, you can use H2O for Kaggle and do very tiny little data, but this talk is going to be for big data. That's why the group is called Big Data Science, right? So in the past, it was tough to do big data science because we were only doing Hadoop and MapReduce and Ping and Hive scripts and premises. But now with Azure and all these great things, you have Spark, and then you have things like H2O or R server. These things are making it a lot easier, kind of like working in one computer. So he's going to go through that and a couple of logistic things. We're running out of water, but if you need more water or ice, you can go to the kitchen over there, and there's a machine free, so you can use it. And let me Jorge. So Jorge is a good friend of mine. I know him for the last 3 years. He recently joined H2O, and he's finishing his master's degree. He's doing something cool. He's doing cognitive radios, which is RF frequency radios that communicate in any frequency. So they have to find a frequency, the best frequency to communicate with using machine learning, and then communicate to the best frequency, which is another. It's a different concept of radio wave communication radios. And he actually an intern in H2O, and he was key in the design and implementation of H2O sparkling water in Azure. So without further ado, I'm going to introduce Jorge and you take it from here.
Thank you very much, Pablo. So I think most of you already completed the step, but before we start, if you want to follow, go ahead and create a new free trial Azure account that is going to give you 200 credits for a month. That's way more than enough that we're going to use today. You just go to this website, or you can just Google Azure free trial, and it will take you the first thing. The second step is actually going to this GitHub repo, and you're gonna see a deploy to Azure button. If you just click that, it will take you to Azure. Just follow the steps and click Azure. I'm seeing people that are having problems with the core quota of the free account. If you have problems, maybe set the VM count to 2 or to 1, or maybe change the size. Instead of having the standard VS3, just the standard VS11 that has less cores. So the whole process, it should take maybe 10 minutes. Okay, so we're gonna start while we wait. What is H2O? Well, H2O is basically open source, in-memory, distributed, fast, and scalable machine learning and predictive analytics platform. Basically, your workflow when you're a data scientist, you're doing machine learning. Is basically, the first step is you get your data, you do your data munging, you do your data cleaning, you do your feature engineering, and then you have to build and validate your models on your data. This is really where H2O excels at. We have many models. I'll show you a quick list of all the models we have. And another key feature that we have is that once you are happy with your model, you can download it and deploy it on production just by a few clicks. You just download Apoyo. We call Apoyo is a Java object of your model, so you can just deploy it on production, no hassle. Another thing, H2O basically exists in whatever environment you do. If I'm a Python guy, but if you like R, we have H2O on R. We have H2O on Python. If you're doing big data science, we have H2O on Spark. That's an application called Sparkling Water. And we also have the like pure H2O from the command line that you will get. So a few data science we have k-means, GLMs are general linear models, DRF, Naive, PCA, GVMs are very hot right now. GRRM, deep learning, another really hot model right now. And we have something called stack ensembles. If you went to Kaggle, if you know what Kaggle is, you know that stack ensembles are the way to go. It's just basically you build little models and you stack one on top of the other to get a better overview model, right? So the topic of this meetup is basically we're bringing H2O to Azure. So why are we deploying on the cloud? Why are we deploying on Azure? Starters, Microsoft Azure provides an immense collection of cloud services, and they're all backed up by the amazing Microsoft network. But the trends in data science are going big data. Like a few years back, you could still maybe use your work PC to do data science. If you have like an 8 GB laptop, 12 GB laptop, you still do data science on your computer. And most of the cases, if not all these days, this is no longer a case. This is no longer an option. So you have two routes. You either go and get a big on-premise server for your data science, or you go to the cloud. And obviously, the most efficient option is going to the cloud. If you don't believe me, if you know Kaggle is a website for data science competitions, where data science is really came with amazing solutions for real problems. And a few years back, when Kaggle started, you could use really like the most crazy model you can think of on your laptop. And if you enter today to Kaggle, I will have a hard time running whatever competition they have on my laptop, because the size of the data sets are so much bigger. And a fine story I have is last year I was doing Kaggle, and I was talking to Mark Landry, that is one of our Kaggle masters here in H2O, and we were basically running the same competition with give or take the same setup. And I was having horrible memory problems. Yeah, really. When you start struggling with memory on your laptop, is changing double precision float point to single precision float point, it makes a whole lot of difference. And I was talking to him. I was telling him how I was struggling, and he was like, I don't have this problem because H2O, like I said before, is extreme memory optimization. Uh, but still, um, you want the cloud because it provides something else. It provides the elasticity. So if you have a big data set, you can take your deployment or create a big deployment, work on your data, and then just shrink it back to your everyday PC. That's not something that you can use with your laptop, right? Um, and another thing is this elasticity makes you efficient about the resources you're using. Um, you don't want to go to Azure and just create a huge cluster of machines just because you can, and you can do it in 5 minutes. But you risk the the opportunity to kill a fly using a bazooka. So basically, you just want to have this elasticity to fit your workstation to your data, and that's the best ability you have on the cloud. So today we're going to do two demos. Um, since most of you are new to H2O, we're going to use the cluster that we're setting up, uh, and we're going to use some Python and R code H2O so we can see how easy it is to use H2O. And the second demo, and for it, I'm actually going to ask you to see me instead of doing it yourself. And we're going to show the H2O sparkling water for HD Insight. And the reason is the cluster for HD Insight actually takes a half an hour, so I don't want to waste you all's time waiting for the cluster to create. So we're going to start right away, and we're going to start the Azure demo. So I think I went too fast, but if your deployment finish, you should see something like this on your Azure portal. If not, then you just hit this button right here. This is the resource group, and you search for the resource group that you created or selected while doing the first step. And I'll be honest, it actually looks quite threatening because the templates does so much stuff for you. Well, basically what we want to see is we have 3 VMs. That's the 3 node cluster I created. We can select any one of these. Just go to the 0 if you want to, and you'll see that it has a public IP address and a DNS. So we're gonna to connect to this cluster. We're gonna copy the public IP address, and we're gonna go to so HTTPS and port 8000. This will connect us to the Jupyter notebooks that comes with the machine, and the template you guys run just do this for you. So if I may ask, what kind of IDEs or platform you use to develop usually? Okay, so what kind of IDEs or platform do you use when you develop? Anaconda. So, and Python or?
Yeah, I use Jupyter.
Okay, so I personally love Jupyter, especially if my application is contained within itself, because it lets me um, prototype and test really fast. So that's why we have Jupyter Notebook installed in this template. But if you like a more IDE experience and you are our guy, you can actually go to the same IP address, the port 8787, and this will show you to RStudio server. This is on your browser where you get the same lookalike of an IDE. So I have here two demos, R demo and a Python demo to show you. We're gonna see the R demo first. I'm gonna stop and really look at it. So this example is for the IDE I-state classification. This is one of the examples from Hernandez, one of our star data scientists in H2O. And we're basically gonna see the H2O R API capabilities, and we're gonna create a model and we're gonna see it. So if you want to do this on your personal laptop instead of using Azure, the template we're using, you just run this code to install H2O and all these dependencies. So I already run this like half an hour ago. The first thing we need is to start the H2O cluster. So the H2O cluster, we see it has a total of 32 gigs of data, because we have three machines, about 14 gigs each, I think, and we have 12 cores. So of course, if you already have a running, and you might want to use init instead of start, and you just put the IP and the port, so you can actually, instead of using these Jupyter notebooks, you can use your own Jupyter notebooks that can connect through the IP address that we're using. So the first thing we're going to do is we're going to import a file, and import a file is just an easy as one line, just import file, more straightforward can it be. So let's the dimension of the data, it has 16 columns and almost 15,000 rows. So this R, we're gonna use kind of look at how the data looks like. We see we have a lot of measurements, and we have the eye detection. That's gonna be our label, and the split column is a column we did with these data sets, just basically to compare H2O against other algorithms. So here are the data. Our eye detection, like I said, is our response column or label column. And we're going to ask H2O how many unique values the label data has. So it's basically H2.unique, easy. We have only two, basically a binary data. So we want to tell H2O that that is our label, that is our target. And we do that by calling this function as factor to the data. So what we did is we replaced that column with an equal column with a different type. And just to double check, we ask how many levels does this data has, and it's 2, and it's 0, 1. if the response would have been true or false instead of 0 or 1, we still can do the same as factor, and we'll still get the 0, 1 level. So we're gonna count how many NA we have. Just make sure that the die is clean, and we have no NAs. That's great. Same for the rest of the data. So now we want to see the distribution to see if it's a skew data set. We see the eye detection rows are 8,000, and for yes is almost 7,000. So it's not exactly distributed, but it's not as bad. It really is not as bad. And just number of training samples, like the ratio. So the first thing we're going to do, and okay, so this is a step where you already have your data, you kind of have your feature engineering. Now you want to split into training and test and validation, just to keep yourself real grounded, that you're not doing overfitting, because overfitting is a public enemy number 1 of a data scientist. That means that your model is saying everything is great, and whenever you put new data, then everything it's wrong. That's public enemy number 1. So the best advice is just split the data into train set, a validation set that you're gonna use to validate your, and then a final test set, just to like give a final performance of your model. So we're gonna use and train a GVM for this model, and it's as easy as set basically what are the data columns, right? So everything but our label and our split, and the model is really easy. It's just GVM, just pass the training frame, the validation frame, the distribution. We're using Bernoulli because it's a binary. The numbers 3, 7, and learn rate, and that's it. You hit enter, and you will see array around it, but you will see actually this little bar go to 100% real time. So we want to see the model details after it already trained and see how well it did. And so we can actually use print model, and it will come with all kind of a summary of your model. It has the mean square error, the root mean square error, the AUC, and this is again just because it's a binary, and we see that it's 94%, so it's really good. It's a really well. And we see more metrics, so max F1, max F2, and we see the confusion matrix and see where the errors happen. All these errors and metrics are reported on your validation set. So it's not your training set, because your training set is going to be always great, right? So your validation is the one you want to see when you're training. Okay, so we're gonna perform on the test set, and we see that the AUC is and the R2 92%, 52%, so it's still really good. And compared to our validation, we're still within the same. So there's no worries of overfitting here. So what happens when you don't have that much data? You can actually do cross-validation. Cross-validation will be you just split your data sets in k little partitions, and you use k-1 partitions to train and the kth one to validate, and you use that for all partitions. So actually takes long, but it's a better way to validate. And again, it's the same structure that I used before. The only difference is we added a new parameter called number of folds. So this is going to be a 5-fold cross validation. And again, we're going to see the AUC for training, the AUC for validation. We see that it's still close, so we're still good. And the last option we have is now, okay, so we want to do more. We're greedy, and we want to see what are the best hyperparameters that we can have. And we can really create a list of hyperparameters in R, and we can pass that list to our same, well, it's not the same, it's going to be the grid, the grid method, and we're going to say, okay, so now I want you to build me a grid algorithm in GVMs with all these parameters and see how well it does. So
these parameters. That means we are already giving them the information to the model to run on these such parameters.
Yes, you're telling what parameter, and there's a risk of overfitting there, but you still are keeping your training frame and your validation frame separate. Like it will still run all your training on your training set and your validation. So you still keep some sort of control against overfitting. But yes, if you finely tune the higher parameter list, you will do some sort of overfitting eventually. That's why you want your test set untouched. We haven't used the test set. And the grid details, we can see we have very good models, very bad models, and you can just, if your list is very big and you just want to see the best, you just tell me what the best model is, basically, and just the first element of the array, and the performance on the best performance on the test set. So we see that we have 97% on the test set, so good. I want to show you another demo, and this is going to be the Python demo, and we're not going to be into such detail. I want to tell you that the H2O API is the same form and shape in every platform. So there's no learning a new thing. As if you go from R to learn the Python APIs, it's basically the same. This is what I love most of H2O, to be honest. Same thing with starting. Import file, same thing. So this is a little bit different because this is pure Python. So shape and head and the columns. This is another example, but it's basically the same target. You want to predict a binary data. You have B and M, and yeah. So we don't have, again, we don't have any no missing labels, no that I know it was still the same. But I actually want to go and see. Oh, you just use a split of the frame. You put the radio, and you have a train and test. And here's the good part: the GVM model looks a lot like the GVM on R, and the parameters are basically the same. This Bernoulli distribution, because it's binary, the max tree, the max step, and the learning rate. And it's just train, and you pass the train and your validation. And for inspect the model, same as before, we print the model, and we're gonna have the same the same summary that we have on R. And for cross-validation, do the same thing. We add the number of folds and we train. And for the grid search, again, the same thing. We use the H2O grid search, and we pass the model that we were using before, the GVM, and the hyperparameter list. Train and compare, same thing, which is great. Okay, so you can use either Python or R, and it's going to be basically the same code, which is great. Now, I want to show you the second part of the demo. Is going to be the sparkling water application in Azure that we just released. Like, it just came maybe last week.
Let me introduce that.
Okay, go ahead.
So it was been going on right now. So what he did, he followed it. It's went to his GitHub repository, click the deploy button, and it will create as many machines as this tell it. Individual VMs. The underlying VM that H2O is using is called the Azure Data Science VM. The Azure Data Science VM has a bunch of things that you're going to love. It has RStudio, OpenClaw, it has Villapol, TensorFlow, I think that's it. It has XGBoost, it has SQL, it has a lot of things. So what the template does is put H2O on top of that. What it does is put H2O on top of that, pull the scripts to put all the machines in a cluster. So when you run that Jupyter, which by the way is also installed in VM, you're just going to type the code, and the machines of H2O is going to talk to each other, and you're going to have cores and memory as much as VMs you have. So you can do basically a big data science with H2O in Azure by running this script. Right now, you have to go to his repo, but in about 2 weeks from now, you're probably going to go to H2O.ai, have the deploy button right there, because you're not going to remember either. Okay. So what it's going to talk about right now is, okay, now that that's good for small data, even though you can do as many VMs as you can, you're probably going to have your big data on top of Hadoop. You're not going to have your big data on a S3, because then to download that big data to your H2O standalone is going to take forever. Normally, enterprises have their data on a data lake. And data lakes are made out of Hadoop. Unless you have something new, Hadoop is the data lake that 99.99% of people do, correct? And it's normally Cloudera or Hortonworks or Mapr. Okay? What Azure does, it's, okay, people that want to do it on premise, you can have H2O on premises, forget about Azure, the cloud, and you can install that on top of Hadoop. But if you have Spark, then you do sparkling water H2O. Okay, so you have H2O, you have Spark, and you have Hadoop. But if you want to move to the cloud, then you're going to use HD Insight. HD Insight is a cloud version of Hortonworks. Hortonworks, if you're used to Hortonworks on premises, is going to be 100% compatible with HD Insight in Azure. So people say why Azure is getting so much momentum on the enterprise is because every enterprise that Hortonworks, when they go to the cloud, is a pretty much copy-paste code. Okay? You have to load the data, of course, but it's Hortonworks in the cloud. So what he's going to do is say, okay, if you're actually going to do data science on big data, your data is normally in Azure in 2 places. On Azure Blob Storage, okay, and Azure Data Lake. Azure Blob Storage has some limitations on I/O, has some limitations of the size of the files, has some limitations on the amount of files you can have. It's big, but it's not big data. It's not petabyte or simple. So Azure came out with the Azure Data Lake Store, which is an unlimited space, unlimited unlimited no, that would be God. Unlimited size of data, unlimited numbers of files, and very high throughput. So you can have your data in Azure Data Lake Store. On top of that, you put HD Insight, and the Data Lake Store is going to be your HDFS system. HD Insight with Hadoop and Spark on top of that. And that's good for sparking and Hadooping or whatever you're going to call it. But then you're going to face, okay, now I want to predict. I want to actually do a machine learning, a deep learning model. And you're going to have a very nice time finding a good library that fits on top of Spark and Hadoop that can do very easily machine learning model. Azure or Microsoft has a native first-party solution for that called R Server, which I love because it's R code, distributed R. And you can do R code on your machine and then export the same code to do on top of Spark and Hadoop or HDFS. But what I think is the best platform is HDInsight on top of Data Lake Store, HDFS, HDInsight Hadoop with the Yarn, the negotiator, and then you have Spark, and then you have H2O on R Server. Both. With R Server, you get a lot of R code wrangling. There's no learning curve on that. But then H2O shines on modeling and the models, deep learning, GPM, DLM, Kaggle style accuracy. Right? So when you have all of those stacks together, you really have a good platform for data science. And also H2O will help you productionalize that. So you have your code ready, your data model, your model, put that into a Java object, wrap it around Tomcat, and have a web service tool ready to support. Okay? So what he's going to go through is, okay, now that you already saw data science on multiple ends, now you will see big data science on top of HDFS. Are you going to do Data Lake Store?
I'm using Blob.
Blob storage. So it's going to do blob storage. It's going to have Yarn, HDFS, Spark, and H2O. So any questions before he starts with the demo?
Just give a architecture of that one, what gets like, we get to understand.
Okay, what did you say?
Yeah, we get architecture that.
We have one. I don't know if you have it, but I have one. The architecture what I just said. Okay. I'll put a nice dash on the group after this. But I'm going to say it again. It's going to have blob storage for all the big data. It's going to have actually Insight, which is give you Yarn or HDFS. Spark on top of that, and then H2O talking to Spark. And where he's not going to demonstrate R Server, but you can also have R Server in the same platform.
But the models on H2O, doesn't those models reside on R as well? So GBM, so that package doesn't reside in R.
No, the model is H2O code. It's not R code. It's not the R.
Okay, so there's no similar package in R that does GBM model. Like
There are packages that do GBM R.
yeah, so what's
They're not as good as H2O, and they're not the main thing. They're not distributed computing.
Yeah, but our server does that, right? Distributed.
Yes.
So why would you want to? My question is, why would you want to pull one versus another? Why are we complicating the stack?
Well, yes, there are some models that are the same in H2O. There are some that are not. That are here. That are not here. Python API with H2O. If you're a Python over our server, that could accomplish for you. And not only that, but the productionalization is very easy with H2O, and you have to load, which is the UI. You're going to show flow.
I'm going to show flow.
And you don't have that UI with our server. So personally, and I do this every day. I do weak exercise every day. That's what I do. I like data munging, data wrangling with R. I like modeling with H2O. Productionalizing, depending on what the customer likes, we can do that. But I like to have all of them. And the pipeline sometimes it is Spark. But when you have R and you have H2O, sometimes Spark is too complex. If you love Spark and you love Spark, and fine. But I tend to not use that many of the Spark functions because they are our server, and H2O give me a very nice function that I can do my data. So, is that a great question?
Here, the H2O, you're using this as a tool kind of thing to do all you require in that.
So what?
The H2O, you're using like a tool kind of thing. You prefer that everything in R. Okay, you H2O, you choose some model you like to analyze your particular score or analyze data. You're using H2O for that?
You can use H2O from the beginning to the end. To do the modeling, to do the wrangling, and to do the productionalization. You can pick one. I personally like data wrangling with Spark, R, and H2O, depending on the function is easier. It's faster, right? And then I use for modeling, I prefer H2O. Yeah. Then for production, it depends on what the customer wants. I can use H2O. Production or post or plain object, or I can productionize with R.
But you could productionize from machine learning, right?
From Spark ML?
No. Azure ML.
Yeah.
You could do that.
You can also do that. ML Studio, as of today, is not big data. Right? 1 terabyte ML Studio. Yeah, so H2O Studio, for those that doesn't know it, it's a very nice studio that you can drag and drop that assigned for beginners. No coding. But it's not big data. It's good for 10 gig of data.
Functionality in Azure ML where you can publish the project as APIs, that's available.
Correct. If you're doing small data, Azure ML easy. Boxes, do what you want, connect it together, deploy as a web service, you have a web service. Boom. But this group is big data science.
No,
That's another.
when I asked you to check your production ready model, is there a function, I think you described that you can write your wrappers in Java.
If you have your model on H2O, you can easily export it to Azure ML.
No, I'm not asking you to publish it there, I'm asking similar functionality contained within the H2O.
Oh, what H2O does for productionizing?
Yeah. Is there a similar ease of deploying that built on
Not as easy as Azure ML, because Azure ML, you said web service, boom, I actually give you the endpoint, the URL. With H2O, it will give you the Java object, it will give you the Java code. You have to wrap that into a web service or Tomcat service, and then you have it. There is a product called Steam in H2O that will do that for you. So you don't have to do it unless you want to. You can use Steam, productionize the web service. For more questions, by the way, there is H2O in here, H2O Superseller Josephine. So if you're enterprise, if you work on enterprise and you want to try H2O, Josephine is the plan. More questions about Azure before I go with him?
Advantages of using H2O with what are the advantages we get using H2O with Azure versus we use H2O with AWS?
Type in a question.
Don't use little bit. Main advantage is that right now, H2O is deployed in the marketplace in Azure. It's not in the marketplace of AWS. So half of the work that you have to do to make it happen in AWS is already done here. So when you, and it's going to go, when you go to the marketplace in H2O, you say sparkling water, deploy. It will create your HT insight, which is the equivalent of EMR in AWS. It will install H2O. It will install an edge node. It will give you the flow there. No IP thing. You don't have to do anything. When you do it in AWS, you do all that manually. And you're going to spend quality time. And over here is like this template. You just click it, doesn't make as you want it, and it's just easier. I personally like HT Insight better than EMR because it's backed up by HTTP, which is works. So for enterprise, that migration is easy. It's the same thing. With EMR, it's not the same. That's your question?
It doesn't go down, huh? Like with the
No cloud is 100%. Actually, we'll go down at some point too.
I think they had issues today, right?
You know, the problem with the cloud is not the cloud. It's that all the websites that went down, when they went down, is because they didn't architect it for redundancy. So if you had architected S3 for redundancy and have multiple regions, that would be good.
Because money. So everybody can talk about that.
It costs probably twice.
Cloud is HA not, but to get the HA costs money, and that's what people.
Yeah. So we got 99.9% with one region. One the extra 99, you have the two regions of double the points. So, but it will go there. So without further ado, please.
Okay, so for H2O Sparkling Water on Azure, we're gonna go to the Azure portal, and we're gonna hit New. This will search the Marketplace. So we're gonna go right to the point and search for H2O, and you're actually gonna see this H2O for artificial intelligence for HT Insight. This is an application that's live right now. If you go right now to your portal Azure, you're gonna see this. And again, is H2O for Spark based. So you just go and hit create, and it's gonna take you to basically the UI to create an HT Insight cluster. So you can go for a quick create, like this is a default, or you can actually customize and add applications or modify the size, add a different setting. So we're gonna go and use H2O test, right? And the cluster login and username, it's gonna be your access to your cluster. So instead of before on the cluster of VMs, you just connect to the public IP. Here you got a little bit more of security, and if you use that Lake store as your primary storage account, it's gonna be even more security with Azure Active Directory. But we're not gonna be into detail right now. So we're gonna use my demo backup, and I'm gonna hit next. Just checking, yeah, we're good. So for my storage account, you can select, like I said, either Azure Storage or the Lake Store. For simplicity, we're gonna use Azure Storage. Well, let's create a new one. H2O demo Dallas, and that's done. So this is the H2O application. So here we just review the legal terms of H2O. It's open source, so you can read it. You have useful links like the documentation. You can actually go to the documentation for H2O with Azure. You hit purchase. And this is gonna be the last step. Is gonna show you the summary. Basically, you're creating a Spark 2.0 cluster, and the size. So the default size is gonna be 2 head nodes, D2, V12, and 4 workers, D4, V2, and 1 edge node. That's where H2O is gonna be hosted, and it actually tells you the estimated cost per hour. We can modify this after deployment, if you say you create your cluster for enterprise, and then you make a big cluster for whenever you're working, and whenever you're not working, you just downsize it to the minimum to keep the cost low. So let's hit create, but I already have one for you to show. So whenever your cluster is created, they're going to take you to this site. So the first URL you're going to see is that you have a particular URL for your cluster, and that is your cluster name .azure-hd-inside.net. If we go to that website, I have it here. If you go to that website, it's gonna show you to this dashboard. That's basic for every HD inside cluster. So every HD inside cluster is gonna give you this varied dashboard where you can quickly overview your cluster. But we actually want to see the same thing that we did before. So we're gonna go to H2O dash. So basically your cluster dash Jupyter, and that's gonna go to Jupyter notebooks, and we're here again. So we have H2O PySparkling examples. So we know PySparkling is a Python-like API to work with Spark, and we have two examples here. So we have a Chicago crime demo, a quick start, and a sentiment analysis. So for the sentiment analysis, I already run it because this actually takes a little bit of time, because we're talking big data. We're not doing the same quick demos that we did before. So the first thing we need to check is how many resources are we gonna give our Spark application. So think that each notebook that you run, it's gonna be a Spark application within his own, and you have to allocate the amount of resources. So by default, it's gonna be 21 gigs for the driver and 21 gigs for the executor, and we're gonna have 3 executors. That's the default value of HD inside. So it's very simple. So you just have to modify these 3 lines. Like if you want maybe share your cluster with other people, you just allocate less resources. For more information, you can always go to the documentation. Here, you're just gonna go to the H2O documentation side. Here it's gonna basically go through the same thing that we're doing, and we're gonna start our H2O cloud. The same thing that we did before, a little bit different. So we use get.create, and we give the Spark context, and we have again our H2O cluster alive. So for this forward, besides the little data engine that you have, basically it's again H2O is basically the same that we did before. So again, upload file, easy. We can review, we can show. This is a Spark data frame. But I actually want to show you. So we can go to this back. So we have a little data engine with the Spark API, and you can go back and forth from Spark and H2O, because they sparkling water that is H2O over Spark share and the same architecture as Spark. So you can basically go back and forth. I'm gonna show you. Yes. So once you have your data frame, you can just import as H2O frame. and you're good. Like you're again back to H2O. You can split frame, and you can do your grid search like we did before. So we have our hyperparameters or search criteria, and we just launch like we did before. H2O grid search, give me the estimator. We're using deep learning for this case. And for training, I want this training set and this validation frame. And that's it. So, but I want, well, these fronts, I think I want to show you flow. Flow is another way to work with H2O. So you can work, as we said before, using Python, using Spark, using R, but we can also use Flow. So Flow is a really amazing API UI. It's available by your cluster name -h2o.apps.ht inside. So I'm going to show you here how Flow looks like. So this is H2O Flow. It basically works the same as a Jupyter Notebook. Is the same run cells technique, but we have a few clicks that we don't have in Jupyter. So first, we can see the status of the cluster just by clicking status, and we can see that we have 3-node cluster. That's our default that we said before, and each one has like 21 gigs of the data. We can see the water meter. This is the CPU meter. Checking. So let's do it again. Okay, so the water meter is show you basically the status of the CPU of your cluster. Right now we're I think all the models are already run, so it's idle. You can also see, so one of the most important things when you're running big data is that you want to see how your model is performing real time, and H2O lets you do that. So for models, we can list all models, and we see that we have our grid search that we did in our Jupyter Notebook example. And these are all done, but if any one of these were still running, you can just click on this and see how well it's performing. So this is going to show you the same summary that you do when you print on your Jupyter Notebook, but just way better. You're going to see, you just see the graph, and this is this log loss for your training and your validation. You see curve and the variable importance for these, and we see much metrics. So we can also see, if you're happy with this model, we can also see the POJO, the data, the Java object. So if we click preview POJO, we're gonna see the auto-generated Java code for your model. This is all your weights. This is your model basically. This is your model on Java code that you can quickly go and deploy on production. So I'll show you again examples from Flow. So you don't actually have to go to Jupyter Notebook or maybe the Spark shell to work on H2O and then look at the results. That's what I like to do. I like to work on Jupyter Notebook on my background and see how my models are working on this beautiful UI. But you can also work from here, from start to end. So let's do the airlines delay. So it's also a notebook. Okay. So same as the Jupyter, you can import files, parse the files. We're gonna run out to see how it looks like. Okay, so while this is running, this is not only available for HD Insight. This comes with every instance of H2O that you have. So if you have running H2O on your laptop, you just go to localhost and the port 54321. I still have the cluster VM that I showed you before. So if you go to the same public IP address port 5432, you're gonna have a flow, and you can see all the models that we have, the EVM models that we have before. So let's see the grid model. So you see, and it's basically the same. You can import data just by import data and pass a path. You can create models just by clicking do a distributed random forest, and you can select the training frame that we have. So these are the training frames that we have, and this is basically just the same as we did in code, but just clicking. Let's go back to, so this is the airline delay, and the workflow is very much the same. So you still, you first import your files, then parse it, and then you have your nice table. You have for this that year, month, flight number, airtime, and the delay. So what we're trying to do here is basically predict the delay of a flight, right? So we parse, so we now have our H2O frame as our table, and we're gonna build the model. Just click, you can copy this, or you can just go to model and just do gradient boosted machine. And you're gonna see the scoring history. So basically just the same. Your variable importance, and again your pollo. You can use deep learning, same thing. So basically you can work with H2O whatever you like. You can do just flow, you can do just Python, you can do Python math plus flow. That's what I like. You can do R. So any questions from here, from flow, or from the HD Insight? I want to take notice that we didn't do any different from, like, we only do some steps different from Spark to Python to R. So it's basically just the same workflow. So you can just maybe sample your data, work on Python, and then import your work to HD Insight. It's going to work the same.
That's very important what he said. He didn't use that much Spark code. If you only use H2O API of H2O functions, the data munging for modeling and for prediction and scoring, is the same code, whether it's computer, or is it Spark, or is it H2O Insight. Now, if not the same code, you can use the Spark code, right? Because then you cannot do that on your machine. You can, but it's not going to be distributed. So what he said, hey, whether you work in R or Python or in your machine or a cluster of standalones in Azure, on premises, in Spark, H2O Insight, if you use only H2O API, it is the same thing. So that is something cool. Our Microsoft Azure also has that premise, same code everywhere. Okay. There are certain things that Azure has that H2O doesn't, and vice versa. That's why, and I see someone say so many options. Well, yes, but use them all together. And in Azure specifically, you can use them all together. And that's a good deal. However, or someone of you use Databricks, you know what Databricks is? The company behind Spark. Okay? They have a nice, very nice UI that you can have Spark and save on a table and save an S3 and use Spark instances and native. What he did here quickly is create kind of a Databricks environment, which you have a Jupyter notebook. You can save your Hive tables persistent, so you can kill the Spark cluster, put another one again, and call those tables, so you can save your work. And then you can also have H2O with a nice flow. And then if you add our server to it, you'll have the best trilogy to work on big data science. There's going to be another meetup next month or a month and something from now, which a friend of mine, which is over here, here it is. Scott Donahue over here is the master of our server. And he's gonna do a presentation a month and a half or a month from now. Okay, you're gonna see it. And then hopefully you can understand that the three of them together, it's a better story than Spark only or server only or H2O. And that's what we're trying to do in Azure, is to bring all that so people can have the best breed of what is out there, whether it's open source or Microsoft branded. Does that make sense? Continue.
We still have some time to Q&A. If you have any questions later, you can always go to our documentation site and search for using H2O with Azure, and this is gonna explain basically what we saw today.
H2O questions to him. Data science question: how do I use BLM, BVM, deep learning? How do I do research? That's him, or anything that he will tell you to. Sales question: how do I have H2O support? How do I have the best data scientists right now on my company to help me? That's Josephine. And Azure, H2O, Microsoft R questions. Okay. So, is that all I've had?
Yeah.
Q&A if you want. We're going to be here for a little while. The H2O team is Ian, Josephine is here, and Jorge. So get his numbers and emails and all that so you can have support. And I'll be here for Azure. And we're going to do this every month. There's a few guys that come every month. And we're going to do this every month. Next time it's going to be Microsoft our server. So you're welcome to that. Okay? Thank you.
We got on the Jupyter Notebook sign.
The signing?
Yeah.
Oh, can I see? Because sometimes it cannot show like a certificate error. So you just have to add an exception and it will make it. So for the VM, we're like the problem so it already goes yes, so if you go to the marketplace, right, and you search for, I think it's Linux Data Science VM, Linux ESVM, right, Linux Data Science, yeah, Data Science with the machine.
Oh, that has everything
right
in it?
It doesn't have H2O.
Okay.
So yeah, for adding H2O, you have
So
to.
you demo like you used the first one, the Python, right?
Yeah.
So you use from this one? No.
So we're not using this exactly machine.
Okay.
We're using it as a base, and the template is modified.
So, but when I deploy that template from your GitHub, it will launch that. Oh, but I can see that actually. Can you please show me?
Oh well, it's not gonna show on the marketplace. It's gonna show on my GitHub.
In the GitHub?
Yeah.
That's why, right? Like I deployed the your template on the Azure.
To come out. Okay, so if you go to the it tells you how to get to service. Yes, that's your going to get the access. Yes. Okay, so yeah, I know. Oh, it's actually electrical. Yes, machine learning and applying machine learning processes. That's why I don't know. Yeah. I don't. It's Well, my journey started because whenever I was so yeah. Whenever you have a question about your ideas, if you have that, the only problem is
Yeah, really got a lot out of it.
This is the first meetup that you come?
No, well, so yeah, first meetup with this group. So we located in Flagstaff, where that was for very
What company?
galvanic.
Galvanic.
So